Hello everyone, welcome to MH Math Academy's KCET Crash Course 2025. In this lecture, we shall start with the chapter Trigonometric Functions. If I have to just take you through whatever you have learned in the chapter Trigonometric Functions, I'll just list down the concepts. In the first portion of the chapter, you had learned the measurement of angles, in which you had learned two units of measurement of angles. The one is degree measure and the other one is the radian measure. You had also learned the relation between the degree measure and the radian measure of the angles. And then you had learned the relation between uh, the length of the arc, radius, and the angle made by the arc at the center of the circle, which was, I think, you had learnt it as L equal to r theta, where theta was measured in radians. Okay, and there were a few problems based on this result. I request that you go through those particular problems. And after this, you had learned the sign of the trigonometric functions. You had defined the trigonometric ratios as trigonometric functions, and you had learned the domain and range of trigonometric functions. And after that, you had learned the sign of trigonometric functions in the quadrants. Okay, uh, I think, if I remember, around between 50th and 55th page of your NCERT, I think, to be precise, 52nd or 53rd page, there is a table in which they have given in which quadrant what happens to the trigonometric function. In the first quadrant, a function increases from so and so to so and so value and all those things. So I suggest that you go through that table, and rather than going through that table, I suggest that you learn the graphs of all six trigonometric functions, and keep them in your memories. Okay, and then going to the next part of the chapter, you had learned the trigonometric functions of sum and difference of angles. Okay, the results of the double angle formula and all those things you had learned. And also, in this section, you had learned the results on complementary angles also, which are going to play a very important role in KCET. Okay, so I request that you go through each of these concepts that I said just now, and if possible, solve a few problems in NCERT before starting with this lecture, so that you'll be well prepared for the MCQs. And even if you have not done it, it is totally fine. I'm going to revise the concepts wherever it is necessary. Fine. So without any further delay, let us take up the questions. uh, there is a question from 2014 that says, if tan x is equal to 3 by 4 and x is between pi and 3 pi by 2, pi is 180, right, and 3 pi by 2 is 270. So therefore it is in which quadrant? It is in third quadrant, right? So x is in third quadrant. Then the value of cos x by 2 is, that is what they have asked. Okay, fine. Now what is given is tan x. Okay, tan x is equal to what? 3 by 4. This is what is given, and they have asked the value of what? Cos x by 2, right? So here the angle that is given is x, and here the angle that is given is x by 2. Okay, how will you convert this tan x into cos x by 2? The one thing is that there is no result that will help us to find out cos x by 2 directly from the value of tan x. Okay, so what we will do is we will express cos x by 2 in terms of cos x. Okay, of course, from tan x we can find out cos x. Once we find out cos x, we will, using cos x, we will find out the value of cos x by 2. Fine. So what I am going to do now is, I know one formula that says cos 1 plus cos 2x is equal to 2 cos square x, right? 2 cos square x. So therefore 1 plus, if I take the half of this angle, it is going to be cos x, which is equal to 2 cos square x by 2, right? So this is the relation between cos x and cos x by 2. From tan x to cos x, to get it, what I'll do is, I know that uh, either I can go with the triangle method, or here what I'll do is I will just use the identities. To find cos x, first I'll find sec x and then take the reciprocal of it. How will you find sec x in this. You know, I know that 1 plus tan square x is secant square x, right? So what is 1 plus tan square x? It is 1 plus tan is 3 by 4, so tan square is 9 by 16 equal to sec square x. So it is 16 plus 9, that is 25 by 16 is going to be sec square x. So therefore sec x is equal to what? Sec x is equal to 5 by 4, whether it is plus or minus. They have said that x belongs to third quadrant, right? So in third quadrant sec is of course negative, so therefore it is minus 5 by 4. So this will give us cos x also to be equal to minus 4 by 5. So this is the value of cos x that we got. So what I'm going to do is I'm going to substitute the value of cos x here. So it is 1 minus 4 by 5 is equal to 2 cos square x by 2. So it is going to be 5 minus 4 is 1 by 5 equal to 2 cos square x by 2. Okay, so if you bring this 2 here, it is going to be 1 by 10 equal to 2 cos square x by 2. Sorry, 2 has already gone there, so it is cos square x by 2. So therefore cos x by 2 is going to be what? Plus or minus 1 by root 10. Okay, so this is what you got. But is it going to be plus or minus? Okay, see, they have said that x belongs to, x is between 180 and, 270. That is in the third quadrant. So therefore, a few portion of x by 2 definitely belongs to second quadrant, and a little portion of this is going to be in the third quadrant. But really doesn't matter whether cos belongs to second or third quadrant. In both the quadrants it is going to be negative. So therefore without much worry we can write cos x by 2 is equal to minus 1 by square root of 10. So therefore it is going to be the option A. Okay, so this is how we can do it. Okay, fine. Let us now take up the next question. The next question says the value of tan 1 degree plus tan 89 degree is. Okay. See, it actually does not say what we have to do. Okay. If the question was like tan 1 degree into tan 89 degree, then we know that tan 1 degree into tan 89 degree can be written as 90 minus 1 degree, 90 degree minus 1 degree, right? What is tan of 90 minus theta? It is cot theta. See, for the odd multiples of pi by 2, that is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, etc., tan of pi by 2 minus theta, tan of 3 pi by 2 minus theta, tan of 5 pi by 2 minus theta, or sine of pi by 2 minus theta, sine of 3 pi by 2 minus theta, or cos of pi by 2 minus theta, cos of 3 pi by 2 minus theta, 7 pi by 2 minus theta. So any trigonometric function, okay, of odd multiple of pi by 2. I mean, I can just write down 2n plus 1 pi by 2, but just for your understanding I'm writing it down. Minus theta is going to be co-trigonometric function of theta, and since this is depending upon whether it is the quadrant of this, it is going to be plus or minus. Okay, so if it is an odd multiple of pi by 2, sine becomes cos, cos becomes sine, tan becomes cot, cot becomes tan, sec becomes cosec, cosec becomes sec. But if it is a multiple of pi, then sine remains sine, cos remains cos. So trigonometric function, for that matter, any trigonometric function remains the same. But if we check the quadrant, we will get to know the sign of it. That's all. So if it is a multiple of pi, then the sign is going to change. But if it is a multiple of pi by 2, then it is going to change to its co-function. Okay, so that's one thing that I wanted to explain here. Okay, so 1 and 89 here are the complementary angles. So therefore 90 degree minus 1. What is tan of 90 minus theta? It is cot theta. So it is cot 1. Tan 1 and cot 1 will get cancelled out. I'll get 1. Okay, but here they have given tan 1 plus tan 89, but they have not said what should be done, right? They have actually indirectly said what we have to do. If you look at the options are in terms of sign. So it is better that I convert tan into sine. How will you convert tan into sine? There is only one way, that is sine 1 degree by cos 1 degree, of course, plus sine 89 degrees divided by cosine 89 degrees, right? So this is going to give us what? This is going to give us, if I take the LCM, I'll get sine 1 degree cos 89 degree. I'll just shift it to the other side. Wait. Okay. This is going to give us sine 1 degree cos 89 degree. Okay. Plus sine 89 degree cosine 1 degree whole divided by cos 1 degree into cos 89 degree, right? Cos 1 degree into cos 89 degree. Fine. So now if you look at it, uh, it is sine 1 degree into cos 89 degree. What is cos 89 degree? It is going to be 90 minus 1 degree, right? It is 90 minus. What is cos of 90 minus theta? It is sine theta. So I can write this down as sine of 1 degree, and I can write this down as cos of 1 degree, right? So what is sine of 1 degree into sine of 1 degree? It is sine square 1 degree plus this is going to be cos square 1 degree whole divided by, okay, what is this going to be now? This is cos 1 degree. Okay, this cos 89 can be written as sine 1 degree, as I said just now, right? So into sine 1 degree. Now you may ask me, why did I convert cos 89 into sine 1, and why not cos 1 into sine 89? I can write this also sine 8, this as also sine 89, right? Why not this? I will just explain it to you in a moment. Okay, in the numerator it is sine square 1 degree plus cos square 1 degree, so it is 1 divided by I have what? I have sine 1 degree into cos 1 degree. See, if you look at what I got just now, it is, in terms of 1 degree. If you look at the options, this is also 1 degree, this is also 1 degree, this is 2 degrees, and this is 2 degrees. So, all I wanted to say here is, if you get 89, it is of no use. Either I have to get 1 degree, or I have to get 2 degrees. So, it is better that I try to converge towards the options rather than getting what I want. Okay, so that's why I converted cos 89 into sine 1. Fine. Now you can see it is sine 1 into cos 1. See, we know that 2 sine theta into cos theta is equal to what? Sine 2 theta, right? So here we have sine 1 into cos 1. If I multiply and divide it by 2, it is going to be 2 divided by 2 sine theta into cos theta is sine 2 theta. What is 2 theta? It is 2 times 1 degree. It is going to be 2 divided by sine 2 degrees. So therefore, what is it going to be? It is 2 divided by sine 2 degrees. That is option D. Okay. So that was the second question. Now, if I have to go to the third question, that is the value of tan pi by 8 is. Okay. Well, see, tan pi by 8, a few of you might have, by hearted the values of tan pi by 8, but it is not actually reliable to memorize because, there is it's actually a human tendency that we forget the things. So, and there is a chance that you might get confused or you might go wrong if you memorize the thing. So, it is better that you get the answers from the scratch always. Okay, so see, we have got tan pi by 8. Do we know tan of any multiple of pi by 8? Yes. What is it? It is 2 times pi by 8. What is 2 times pi by 8? It is pi by 4. We know tan pi by 4, right? What is tan pi by 4? What is tan pi by 4? It is 1. So they have given pi by 8. We know 2 times pi by 8. So they have asked tan x. We know tan 2x, right? Is there any relation between tan x and tan 2x? Yes, there is a relation. What is the relation? The relation is tan 2x is equal to 2 tan x divided by 1 minus tan square x, right? So this is the relation that I have. So now if I substitute x equal to pi by 8, I'll get tan pi 2 pi by 8 is pi by 4 equal to 2 tan pi by 8 divided by 1 minus tan square pi by 8. So for tan, this tan pi by 4 is going to be 1. So if I bring it to the other side, 1 into 1 is going to be 1, minus 1 into tan square pi by 8 is going to be tan square pi by 8, and equal to 2 tan pi by 8. Okay, so this is going to be tan square pi by 8 minus, sorry, not minus, plus 2 tan pi by 8 minus 1 is equal to 0. Now I'll just call tan square pi by 8 as m, so it is in the form of m square plus 2m minus 1 equal to 0. So it's a quadratic equation, right? So what is going to be the solution? We know that x equal to minus b plus or minus root of b square minus 4ac by 2a, right? So here it is going to be m equal to minus b, that is minus 2 plus or minus root of, what is b square? B square is 4 minus 4ac. Minus 4ac is minus 4 into a is 1, c is minus 1. So minus into minus plus 4 divided by 2a. 2a is going to be 2. So this is equal to minus 2 plus or minus, it is 8. 8 is going to be 2 root 2 divided by 2. It is equal to, if you cancel out these two, I'm going to get minus 1 plus or minus what? Root 2. So this is m is nothing but tan pi by 8. Of course, pi by 8 belongs to the first quadrant, so therefore it has to be positive. If I write minus 1 minus root 2, then it is going to be negative. So what I'll do is I'll take plus root 2. So therefore it should be minus 1 plus root 2. Okay. If you go to the options, you have 1 by 2 root 2 plus 1, this one. Okay. So I think they have multiplied and divided it by its conjugate. So divided by, if I take up minus 1 minus root 2 here, and then okay, minus 1 minus root 2 here, it is going to be, you know okay, it is going to be what? If I take out a square minus b square, right? So what is a square? It is minus 1 whole square minus, what is b square? It is root 2 whole square. Okay, divided by minus 1 minus root 2. So it is going to be what? It is 1 minus 2 divided by minus 1 minus root 2. This is minus 1. So minus 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 will get cancelled. I'll get 1 by 1 plus root 2. So it is going to be 1 by 1 plus root 2. That is option C. So option C is the right answer. Fine. So without any further delay, let us go to the next question. That is, just a minute, I will just bring this down. Okay. Fine. The value of sine 1 degree, sine 2 degrees, 3 degrees, 358. See, it's very much obvious that it is impossible for us to find out the values of this. So we have to play around with these terms that they have given. If you look at the, this problem is totally based on a conditional identity, which I am going to tell you in a while. The identity is, if a plus b is equal to 360 degrees, then what is the value of sine a plus sine b? Can I write down? Then sine a plus sine b equal to sine a plus sine b is going to be 360 degree minus a, right? So this is equal to sine a, sine of 360 minus a. 360 minus a is in which quadrant? 360 minus a, if you look at it, is going to be in the fourth quadrant. In fourth quadrant, sign is negative, so it is minus sine a. So it is equal to 0. See, 360 is a multiple of pi, right? Just now I had explained you. For a multiple of pi, sign is going to remain sign. So in the fourth quadrant, it is negative. So therefore, it has to be minus sine a. So sine a minus sine a is equal to 0. Okay. So why did I tell you this? Is if a plus b is equal to 360, then sine a plus sine b is equal to 0. Right. So here, if I take out the first term and the last term, what is it? Sine 1 degree plus sine 359 degree. If you take the sum of these, it is 360 degree. So here A plus B is 360. So therefore sine A plus sine B must be equal to 0. Right? So these two, the sum of these two is going to be 0. Similarly, the sum of these two is going to be 0. Similarly, the sum of sine 3 and sine 357 degrees is going to be 0. Like that, the number of terms here, half of the terms here and half of the terms here are going to get cancelled. Fine. So you might immediately arrive at the conclusion that the answer is going to be 0. But is it uh, definitely 0? How well did you understand this? Look, suppose that I have four terms. Okay, I hope my fingers are visible. Suppose that I have four terms. Okay, out of four terms, if the first term and last term are going to get cancelled, these two are going to get cancelled, right? The first one and the last one. Okay, and then this term and this term, that is second term and the third term, are going to get cancelled. Then in the middle, I'm left with nothing. So these two terms and these two terms got cancelled out and it's gone. So I'm definitely going to get 0. But if instead of 4, if I have 5 terms, then this and this will get cancelled out, this and this will get cancelled out, but in the middle I'm going to get one term, right? So the value of this sum is going to be the value of that middle term if we have odd number of terms. But if we have even number of terms, then it is going to be 0 for sure. But if we have odd number of terms, then these two terms and these two terms are going to get cancelled out. I'm going to get a term in the middle, so therefore it is going to be the value of that middle term and not always 0. Okay, so therefore in this case you can see, I will just erase this one out. Okay, so in this case you can see we have sine 1, sine 2, sine 3, sine 358, sine 359. So from 1 to 359 it is going to be how much? It is going, these are 359 terms, right? So 359 is an odd number, so therefore there are odd number of terms here. So if I have 5 terms, okay, how many terms are going to get cancelled out? 4 terms are going to get cancelled out. I'm going to be left out with one particular element in the middle. So here also I am going to be left out with one particular element in the middle. If I leave it, how many terms are left out? 358, right? So 358 terms are left out. So out of 3, see these 358, if you exactly take the half of it, there are 179 terms towards this side and 179 terms towards this side. Sorry, not degree. 179 terms towards this side and 179 terms towards this side, which are getting cancelled. So after 179th term, which is the next term? First term is sine 1, second term is sine 2, third term is sine 3. So therefore, after 179th term, it is going to be sine 180. Okay, by God's grace, the value of sine 180 is also 0. So if you even if you just cancel out all the terms without having the knowledge of odd and even terms, for this question you are definitely going to get 0. But this is not going to work always, so it is better that you understand this. Okay, if we have odd number of terms, then the value is going to be the value of the middle term. Okay, and if we have the even number of terms, then the terms are going to get cancelled out and we are going to get 0. Okay, I hope what I said here making sense to you. Okay, so without any delay, let's go to the next question. The next question is root 3. See, this CSC is cosec. Okay, you can write cosec like this also. Okay, so root 3 cosec 20 degree minus sec 20 degree. Fine, this is a very beautiful a problem. The such problems have been asked in previous year JEE mains also. Previous, I mean, not in 2024 exactly, but in the previous years. Okay. Why did I say this? Is because suppose that you have, let's say, root 3 sine theta plus or minus cos theta, okay, or root 3 cos theta plus or minus sin theta, something like this, or root 3 here, you know, it's something like this. So if you have root 3 as the coefficient of one term and 1 as the coefficient of the other term, then what you have to do is, if you divide it by 2, if you divide it by 2, and of course multiply it by 2 to balance, okay, divide it by 2 and multiply it by 2 to balance, then can you write down root 3 by 2 as, let's say, sine 60? Yes. Can you write down this as cos 60? Yes. Or can you write down this as sine 30? Sorry, cos 30? Yes. Cos 30? Yes. And can you write down this as sine 30? Yes. So why did I say this is because you are going to get it in the form of sin x into sin y plus or minus cos x into cos y, right? So if you take out minus, I mean if it is plus, then no problem. Cos x into cos y plus sin x into sin y is going to give you cos of x minus y, right? If it is negative, then you take out negative, it is going to give you cos x into cos y minus sin x into sin y, which is cos of x plus y. Same is the case with this one. If you take cos x into sin y plus sin x into cos y, it is going to give you sin of x plus y. And same is the case with sin of x minus y. Here also it works like this. So if you have sin and cos, then you can convert it into sin of x plus y, sin of x minus y, or cos of x plus y, cos of x minus y. Fine. But what if you have cosec and sec? Of course, you can convert it into sine and cos, right? So we will convert it into sine and cos. So what I will take up is root 3 cosec 20 degree minus sec 20 degree is equal to, I will multiply and or else I will do it later on. What I'll first do is root 3. I'll write cosec as sine 1 by sine 20 degree minus sec as 1 by cos 20 degree. Fine. So this is going to be root 3 cosine 20 degree minus sine 20 degree divided by 2 sine 20 degree, okay, and then into cosine 20 degree. Fine. So this is what you have. Now look, here I have root 3 cos 1 sine. Is it similar to what we did here? Yes, it is very much same. So very much the same. So therefore, what I'll do is I'll multiply and divide it by 2. So it is going to be 2 times root 3 by 2 cos. No, why did this 2 appear here? It's not. Just a minute. Okay. So it's cos 20 degree minus 1 by 2 sine 20 degree, okay, divided by, if you look at this one, in the denominator, it is sine 20 into cos 20. So if I have to convert it into just one term, if I multiply and divide this by 2, what I'm going to get? I'll get 2 sine theta into cos theta, right? What is 2 sine theta into cos theta? It is sine 2 theta, right? So to make that, what I'll do is I'll just multiply it with 2, that is 2 sine 20 cosine 20, and then I will divide it by 2. That divided by 2 is of course going to appear here, right? So this is equal to 2 2s are, it is 4, okay, and then I will leave this as it is as of now, whole divided by, okay, 2 sine theta cos theta is sine 2 theta, that is sine 40 degree, okay. Now well, now you see, I can write down this root 3 by 2 as either sine 60 degree or cos 30 degree. Okay. So now I can write down this 1 by 2 as either sine 30, okay, or cos 60. If I write it down as sine 30 and this as, just a minute, this is sine cos, this is going to be cos, first I have to write down cos here, okay, sine 30, okay. If I write this down as sine 60 and then cos 60, what am I going to get? Sin x into cos y minus cos x into sin y. It is of that form, Okay, so what is it going to be? It is going to be sine of x minus y. What is sine of x here? X is 60, and what is y? Y is 20. So therefore it is going to be sine 60 minus 20, which is sine 40. So if I write down 30, it is going to be cos 30 into cos 20. So cos x into cos y minus sin x into sin y, which is cos of x plus y. What is cos of x plus y? X is 30, y is 20. So it is going to be 50 degree. Okay, here in the denominator I have got 40 degrees. So for the cancellation, it would be easier if I consider sine 60, okay, and cosine 60. So therefore, what am I going to write root 3 by 2 as? I am going to write it as sine 60 cosine 20 minus cosine 60 sine 20. So this will be 4 times sin x into cos y minus cos x into sin y. So it is going to be sine of x minus y, that is 60 minus 20 is 40 degrees, divided by sine 40 degrees. So it is going to be, these two will get cancelled out. I am going to get 4. So the answer is going to be 4. Okay. So this is what we have. If I have to take up the next question says the value of sine square 51 degrees plus sine square 39 degrees is. Look, this is going to be an easier question. Why? Because if you add these two, that is 51 plus 39, it is going to be 90, right? So what I'll do is sine square 51 degrees plus sine square 39 degrees. I will convert one of these into cos. So sine square 51 degrees plus, I can write this 39 as 90 degree minus 51 degree, right? So what is sine of 90 minus theta? It is cos theta. So sine of 90 minus 51 is cos 51 along with the square. So it is cos square 51 degrees. Cos 51. So sine square theta plus cos square theta is going to be 1. So the answer of this question is going to be 1. Okay. So that was a very simpler question. Coming to the next question, that is, if tan a plus cot a equal to 2, then the value of tan raised to 4a plus cot raised to 4a is. Okay. Look, what they have given is in the form of a plus b. Okay, they are asking a raised to 4 plus b raised to 4. So there is no other way other than squaring it twice. Okay, so what I'll do is I'll take up the given equation, I'll square it twice. If it gets complicated, then let's see. uh, okay, why am I doing this is because all we can get is the wrong answer. There can be nothing much. So, or we might arrive at a step where we get stuck. Nothing more than that will happen. So it's better that we are not scared with the problems. We'll just approach it. Let's see what will happen. Okay. So we have tan a plus cot a equal to 2. I'll square it on both sides. First, I have to square it twice because I need to get a raised to 4 plus b raised to 4, right? So, okay. This is going to be a square, that is tan square a, plus b square, that is cot square a, plus 2ab, that is 2 tan a cot b. If I'm right. Sorry, cot a. 2 tan a cot a, right? Okay. Equal to 2 square is going to be 4, right? So tan a and cot a will get cancelled out. I'll get tan square a plus cot square a plus 2. This 2, if I take it to the other side, it is 4 minus 2, again 2. So now I will square this once again. I think it's very easy. So tan square a is going to be a square, that is tan raised to 4a, plus b square, that is cot raised to 4a, plus 2ab, that is 2 tan square a cot square a equal to 2 square, that is 4. So tan square cot square gets cancelled. So it is going to be here tan raised to 4a plus cot raised to 4a is equal to, it is going to be 2 again. I think we can make out an identity here. If you square it again once again, it is going to remain the same. Okay, so what we can do here is, if uh, tan a plus cot a is equal to 2, then we can say that tan raised to na plus cot raised to na is also equal to 2. Okay, so I think this is you can check this by induction. I think we will be able to prove it. Okay, so that's all. Fine. This is what we have. Next up, we have this question, which was asked in 2021. They are asking the value of cos 1200 and then tan something. Okay, see, if you get these larger angles as a whole, I suggest that you find out the nearest multiple of 360. Okay, suppose, let's say, what I mean here is, if you get, let's say, find the value of sine of, let's say, 405 degrees. It's obvious that we don't know, right? So what we can do is, we can write this down as 360 plus 45 degrees, right? So what is 360 plus 45? 360 is going to be 360 degrees is going to be one complete circle. Any multiple of 360, if 2 times 360 is 2 complete circles, 3 times 360 is 3 complete circles. So again, you are going to, after this multiple of 360, you are going to, enter the first quadrant again. So your cycle is going to restart. Okay, so those angles what you are going to get after a multiple of 360 are the very fresh angles. So you can avoid that 360 and take the angles alone. So that's what I'm saying. You know, if at all you get the larger angles, try to uh, erase off the multiples of 360 and then proceed. Okay, so what I'll do now is I'll try to find out the nearest multiple of 360 and then let's see what will happen. So we have cos of 1200 degrees plus tan of 1485 degrees. Fine. So this is going to be what? Cos of 1200. So 360 plus 360 is 720. 720 plus 360 is 1080. Right. So 1080 degrees plus I think 120 degrees. Okay. Plus this is 1200, right? The total is 1200. Okay. Uh, Plus tan of this 1485. 360 plus 360 is 720. 720 plus 720 is 1440. 1440 plus 45. So 1440 plus 45 degrees is going to be 1485. Fine. So now you see, this is cos of, this is 3 times 360, if you remember what we did, plus 120. Okay, plus tan of, this is 4 times 360 plus 45. If you just see, we have completed 3 circles and we have again entered the 0 zone after 0 again. So I can ignore this. We have completed 4 cycles, so I can ignore this. So I'll get cos of 120 as a fresh and tan of 45 as fresh trigonometric identity, I mean the ratio. So now what is cos of 120? I can write it as cos of 90 degree plus 30 degree. Okay, plus tan of 45 is of course 1. What is cos of 90 plus theta? I have told you, for any multiple of 90, the trigonometric function is going to change to its co-function. So cos of 90 plus theta would become sine theta, that is sine 30 degree. But cos after 90, that is 90 plus something, is in which quadrant? Second quadrant. In the second quadrant, cos is going to be negative. So it is going to be minus sine 30 plus 1. Sine 30 is how much? 1 by 2. So it is minus 1 by 2 plus 1. 1 minus 1 by 2 is how much? 1 by 2. So the value of this is going to be 1 by 2. That is option A. Okay, that was an interesting problem. Fine. So without any delay, let us go to the next question. But in 2022, it was quite an interesting paper, especially for the trigonometric ratios and identities. Why? Because until 2022, there used to be either one question or two questions from trigonometric functions. But out of nowhere in 2022, we had four questions from trigonometric ratios and identities in the year 2022. So you never know the real weightage, what can we get. Okay, if we are uh, expecting one or two questions. Sometimes we might get more questions also, or we might get not get any question also. So it is better that we are mentally prepared for it. But the questions are as usual very easy, so we don't have to worry about it. Fine. Without wasting much time, I'll take up the next question. The question says, okay, root of what? Looks very odd, but 2 plus root of 2 plus root of 2 plus 2 cos 8 theta. I'm very sorry for my bad handwriting, I cannot help it. Okay, so 2 plus 2 cos 8 theta. Fine. Now, if you look at it, if I take 2 plus 2 cos 8 theta, okay, if I take out 2, it is going to be 1 plus cos 8 theta, right? So we have an identity that says 1 plus cos 2 theta can be written as 2 cos square theta. So what we did, we had cos 2 theta, the angle was 2 theta, we reduced it to theta, and it became cos square. So what I can do is, this 1 plus 2, 1 plus cos 8 theta can be written as 2 times, this can be written as 2 times cos square. I have to take the half of this angle, that is 4 theta, right? So this is root of, this is going to be equal to 2 plus root of 2 plus root of, okay, it is going to be 2 times, okay, 2 cos square 4 theta. Okay, so it is going to be equal to, sorry, under root of 2 plus under root of 2 plus, this is 4 cos square, right? So it is going to be 2 cos 4 theta. Again, if you see root of 2 plus root of, if I take out 2, it is going to be 1 plus cos 4 theta, right? So using this identity, what I can make out is, this 2 plus 2 twos are 4, sorry, 2, no, just a minute, I'm sorry. So I have taken out 2, so it is going to be 2 times 2 cos square, the half of this is 2 theta, so it is going to be 4 cos square 2 theta, right? So what is the root of it? It is going to be root of 2 plus 2 cos 2 theta, right? So if I take out 2 again, it is going to be 1 plus cos 2 theta. What is 1 plus cos 2 theta? It is 2 cos square theta. So root of 2 into 2, 4 cos square theta is going to be 2 cos theta. So therefore it is 2 cos theta. I think it is option B, which is very much obvious. Okay, so that is what we have. The next question is a very simple question. If you look at it, it says sine phi pi by 12 into sine pi by 12 is. Okay, so if you look at these two, what are these? These are the complementary angles, right? How do you say that? Oh, what are the complementary angles? If two acute angles A plus B, I mean A and B, whose sum is 90 degrees, then those two are called as complementary angles, which is a very basic concept of the measurement of angles, right? Now, if you see, they have given sine phi pi by 12 into sine pi by 12. Okay. Now you see, if I add these two angles, what am I going to get? I'm going to get 5 pi by 12 plus pi by 12 is equal to 6 pi by 12, right? So 6 ones are 6 twos are, it is going to be pi by 2, 90 degrees. So these two are complementary angles. So can I write down this sine pi by 12 as sine of 5 pi by 12? See, 5 pi by 12 plus pi by 12 is pi by 2. So if I, take this 5 pi by 12 to the other side, what am I going to get? Or else, what I'll do is, rather than writing down 5 pi by 12, if I can write down this 5 pi by 12 as, if I take this pi by 12 to the other side, what am I going to get is 5 pi by 12 is equal to pi by 2 minus pi by 12, of course, right? So I can write this down as pi by 2 minus pi by 12 into sine of pi by 12. So it is sine of 90 minus theta, which is cos theta. So cos of pi by 12, sine of pi by 12. We have done very similar problem to this in the previous, questions. We have sine theta into cos theta. If I multiply and divide it by 2, it is going to be what? It is going to be 2 sine theta cos theta, which is sine 2 theta. That is sine 2 times pi by 12 divided by 2, which is going to be sine pi by 6. What is it? Sine 30. What is sine 30? 1 by 2 divided by 2 is going to give us 1 by 4. So therefore, option D is the right answer. Okay. Well, now I think this is the last question, the 2023 question. Okay. The value of e raised to log tan 1 to the base 10 plus log tan 2 to the base 10. Okay. See, if you look at this question, it is in the form of log a plus log b plus log c plus log d plus log e, right? So, if you see, there is a property that says log a plus log b is equal to log ab. I hope you know this property. So can I write this down simply as e raised to log of tan 1 degree plus, sorry, not plus, into tan 2 degree into tan 3 degree into so on up to tan 88 degree into tan 89 degree, right? Now look, tan 1 degree and tan, can I write tan 89 as 90 minus 1? Yes. What is tan of 90 minus theta? Cot theta. So it is cot 1 degree. This is cot 2 degree. So if I keep on writing, I'm going to cot 3, cot 4, etc. Tan 1 and cot 1 gets cancelled. Tan 2 and cot 2 gets, again it is those 4 or 5 terms which are, the end terms, and then the penultimate terms are going to get cancelled. Now, if I keep on cancel, tan 3, cot 3 are going to get cancelled. So how many terms are here? How many terms are here? The terms are, there are 89 terms. Out of which, see, it's an odd number. There are 89 terms. There are odd, these are odd numbered terms, right? Odd number of terms. So one term in the middle is going to be there, right? So if I leave that one term, the remaining terms are how many? 88. So 44 terms here and 44 terms here are going to get cancelled out. So 45th term is left out. What is the 45th term? It is tan 45 degrees. What is tan 45? 1. So therefore, what am I going to get here is e raised to log of tan 45 degrees to the base 10, which is equal to e raised to log 1 to the base 10. So log 1 to any base is 0 always. So therefore, it is e raised to 0, which is equal to 1. So therefore, the answer to this question is going to be the option B, that is equal to 1. Okay. So I hope we have covered sufficient number of problems in this chapter. Uh, Okay, in the next lecture, what we shall take up is we'll take up the inverse trigonometric functions, okay, which is again quite important from the KCET perspective. In this lecture, we have not covered one concept, that is, uh, if you remember, there was a result called L equal to R theta, which is the relation between length of the arc, radius, and the angle made by the arc at the center of the circle. Okay, we have not done the problems on this. I request that you revise the first exercise of the trigonometric functions. You will be able to solve any problem on this particular result. But however, uh, I'll try to take up a few problems based on this result as well in the next chapter, and then we will take up the inverse trigonometric functions. Okay, so let me see you in the next video with the concept inverse trigonometric functions. Okay.